Bismillahirrahmanirrahim. My name is Dr. Ayaz Afsar, and our topic today is content analysis and grounded theory. This topic addresses two main forms of qualitative data analysis: content analysis and grounded theory. Many qualitative data analysts undertake forms of content analysis. One of the enduring problems of qualitative data analysis is the reduction of copious amounts of written data to manageable and comprehensible proportions. Data reduction is a key element of qualitative analysis, performed in a way that attempts to respect the quality of the qualitative data. One common procedure for achieving this is content analysis, a process by which the many words of text are classified into much fewer categories. The goal is to reduce the material in different ways. Categories are usually derived from theoretical constructs or areas of interest devised in advance of the analysis, preordinate categorization, rather than developed from the material itself, though these may be modified, of course, by reference to the empirical data. What is content analysis? The term content analysis is often used sloppily. In effect, it simply defines the process of summarizing and reporting written data, the main contents of data and their messages. More strictly speaking, it defines a strict and systematic set of procedures for the rigorous analysis, examination, and verification of the contents of written data. Krippendorp 2004 defines it as a research technique for making replicable and valid inferences from text or other meaningful matter to the context of their use. Texts are defined as any written communicative materials which are intended to be read, interpreted, and understood by people other than the analysts. Originally deriving from analysis of mass media and public speeches, the use of content analysis has spread to examination of any form of communicative material, both structured and unstructured. It may be applied to substantive problems at the intersection of culture, social structure, and social interaction, used to generate dependent variables in experimental designs and used to study groups as microcosms of society. Content analysis can be undertaken with any written material, from documents to interview transcriptions, from media products to personal interviews. It is often used to analyze large quantities of text, facilitated by the systematic, rule-governed nature of content analysis, not least because this enables computer-assisted analysis to be undertaken. Content analysis has several attractions. It is an unobtrusive technique in that one can observe without being observed. It focuses on language and linguistic features. Meaning in context is systematic and verifiable, that is, in its use of codes and categories, as the rules for analysis are explicit, transparent, and public. Further, as the data are in a permanent form, text, verification through reanalysis and replication is possible in content analysis. Weber in his study 1990 sees the purposes of content analysis as including the coding of open-ended questions in surveys, the revealing of the focus of individual, group, institutional, and societal matters, and the description of patterns and trends in communicative content. The latter suggestion indicates the role of statistical technique in content analysis. Indeed, Weber suggests that the highest quality content analytic studies use both quantitative and qualitative analysis of text defined as any form of written communication. So content analysis takes text and analysis, reduces and interrogates them into summary, reduces and interrogates text into summary form through the use of both pre-existing categories and emergent themes in order to generate or test a theory. It uses systematic, replicable, observable, and rule-governed forms of analysis in a theory-dependent system for the application of those categories. Krippendorff suggests that there are several features of text that relate to a definition of content analysis, including the fact that texts have no objective reader-independent qualities. Rather, they have multiple meanings and can sustain multiple readings and interpretations. There is no one meaning waiting to be discovered or described in them. Indeed, the meanings in text may be personal and are located in specific contexts, discourses, and purposes, and hence meanings have to be drawn in context. Content analysis then describes the manifest characteristics of communication, asking who is saying what, to whom, and how. It infers the antecedents of the communication, the reasons for and purposes behind the communication, and the context of communication, and infers the consequences of the communication, its effects. Krippendorff suggests that content analysis is at its most successful when it can break down linguistically constituted facts into four classes: attributes, social relationships, public behaviors, and institutional realities. How does content analysis work? Well, Azzi 2002 suggests that content analysis starts with a sample of text, which are the units. Define the units of analysis, for example, words, sentences, and the categories to be used for analysis. Reviews the text in order to code them and places them into categories, and then counts and logs the occurrences of words, codes, and categories. From here, statistical analysis and quantitative methods are applied, leading to an interpretation of the results. Put simply, content analysis involves coding. Categorizing means creating meaningful categories into which the units of analysis, such as words, phrases, sentences, etc., can be placed. And comparing means categories and making links between them. And concluding means drawing theoretical conclusions from the text. Content analysis involves counting concepts, words or occurrences in documents and reporting them in tabular form. This indicates essential features of the process of content analysis. Breaking down text into units of analysis, undertaking statistical analysis of the units, presenting the analysis in as economical a form as possible. This masks some other important features of content analysis, including, for example, examination of the interconnectedness of units of analysis in categories, the emergent nature of themes and testing, development and generation of theory. The whole process of content analysis can follow 11 steps, which are: step number 1, define the research questions to be addressed by the content analysis. This will also include what one wants from the text to be content analyzed. The research questions will be informed by, indeed may be derived from, the theory to be tested. Step number 2, define the population from which units of text are to be sampled. The population here refers not only to people, but also and mainly to text, the domains of the analysis. For example, is it to be newspapers, programs, interview transcripts, textbooks, conversations, public domain documents, examination scripts, emails, online conversations, and so on. Step number 3, define the sample to be included. Here, the rules for sampling people can apply equally well to documents. One has to decide whether to opt for a probability or a non-probability sample of documents, a stratified sample, and if so, the kind of strata to be used, random sampling, convenience sampling, domain sampling, cluster sampling, purposive sampling, systematic sampling, time sampling, and snowball sampling. We have discussed these in one of our lectures that was on sampling. Robson indicates that the careful delineation of the sampling strategy, for example, such and such a set of documents, such and such a time frame, for example, of newspapers, such and such a number of television programs or interviews. The key issue of sampling apply to the sampling of text: representativeness, access, size of the sample, and generalizability of the results. Krippendorf 2004 indicates that there may be nested recording units, where one unit is nested or enshrined within another. For example, with regard to newspapers that have been sampled, it may be thus: the issue of a newspaper sampled, the articles in an issue of a newspaper sampled, the paragraphs in an article in an issue of a newspaper sampled, the propositions constituting a paragraph in an article in an issue of a newspaper sampled. Step number 4, define the context of the generation of the document. This will examine, for example, how the material was generated, who was involved, who was present, where the documents come from, how the material was recorded and or edited, whether the person was willing to, able to, and did tell the truth, whether the data are accurately reported, whether the data are corroborated the authenticity and credibility of the documents, the context of generation of the document, the selection and evaluation of the evidence contained in the document. Step number 5. Define the units of analysis. This can be at very many levels. For example, a word, phrase, sentence, paragraph, whole text, people and themes. Robson includes here for newspaper analysis the number of stories on a topic, column inches, size of headline, number of stories on a page, position of stories within a newspaper, the number and type of pictures. His suggestions indicate the careful thought that needs to go into the selection of the units of analysis. Different levels of analysis will raise different issues of reliability, and these will be discussed later in the lecture. It is assumed that the units of analysis will be classifiable into the same category text with the same or similar meaning in the context of the text itself. There is a semantic validity, although this can be problematic, and will come to this later in the lecture. The description of units of analysis will also include the units of measurement and enumeration. The coding unit defines the smallest element of material that can be analyzed, while the contextual unit defines the largest textual unit that may appear in a single category. Krippendorff distinguishes 3 kinds of units, that is, sampling units are the units that are included in or excluded from an analysis. They are units of selection. Second, recording or coding units. These are units that are contained within sampling units and are smaller than sampling units, thereby avoiding the complexity that characterizes sampling units. They are units of description. And the third, context units, are the units of textual matter that set limits on the information to be considered in the description of recording units. They are units that delineate the scope of information that coders need to consult in characterizing the recording units. Krippendorff again, 2004, continues by suggesting a further 5 kinds of sampling units. Number 1, physical, for example, time, place, and size. Syntactical, like words, grammar, sentences, paragraphs, chapters, series, etc. Categorical, that is, members of a category have something in common. And number 4, propositional, delineating picture constructions are propositions. And number 5, thematic, means putting text into themes and combinations of categories. The issue of categories signals the next step. The criterion here is that each unit of analysis, category, conceptual, actual, classification element, cluster issue, unit of analysis could be category, and category into conceptual category, actual category, classification element, cluster issue. So the unit of analysis should be as discrete as possible while retaining fidelity to the integrity of the whole. That is, that each unit must be a fair rather than a distorted representation of the context and other data. The creation of units of analysis can be done by ascribing codes to the data. Step number 6. Decide the codes to be used in the analysis. Codes can be at different levels of specificity and generality when defining content and concepts. There may be some codes which subsume others, thereby creating a hierarchy of subsumption, subordination, and superordination. In effect, creating a tree diagram of codes. Some codes are very general, others are more specific. They keep words as words. They maintain context specificity. Codes may be descriptive and might include situation codes, perspective held by subjects, ways of thinking about people and objects, process codes, activity codes, event codes, strategy codes, relationship and social structure codes, methods codes. However, to be faithful to the data, the codes themselves derive from the data responsively rather than being created preordinately. Hence, the researcher will go through the data, ascribing codes to each piece of data. What is a code? A code is a word or abbreviation sufficiently close to that which it is describing for the researcher to see at a glance what it means. In this respect, it is unlike a number. For example, the code trust might refer to a person's trustworthiness. The code power might refer to the status or power of the person in the group. Miles and Huberman, in their study in 1984, advised that codes should be kept as discrete as possible and that coding should start earlier rather than later, as late coding enfeebles the analysis, although there is a risk that early coding might influence too strongly any later codes. It is possible, they suggest, for as many as 90 codes to be held in the working memory while going through data. Although clearly there is a process of iteration and reiteration whereby some codes that are used in the early stages of coding might be modified subsequently and vice versa, necessitating the researcher to go through a data set more than once to ensure consistency, refinement, modification, and exhaustiveness of coding. Some codes might become redundant. Others might need to be broken down into finer codes. By coding up the data, the researcher is able to detect frequencies, which codes are occurring most commonly, and patterns which codes occur together. Hammersley and Atkinson propose that the first activity here is to read and reread the data to become thoroughly familiar with them, noting also any interesting patterns, any surprising, puzzling, or unexpected features, any apparent inconsistencies or contradictions, for example, between groups, within and between individuals and groups, between what people say and what they do. Step number 7. Construct the categories for analysis. Categories are the main groupings of constructs or key features of the text, showing links between units of analysis. For example, a text concerning teacher stress could have groupings such as causes of teacher stress, the nature of teacher stress, ways of coping with stress and the effects of stress. Categories are inferred by the researcher, whereas specific words or units of analysis are less influential. The more one moves towards inference, the more reliability may be compromised, and the more the researcher's agenda may impose itself on the data. Categories will need to be exhaustive in order to address content validity. Indeed, Robson 1993 argues that a content analysis is no better than its system of categories, and that these can include subject matter, direction, how a matter is treated positively or negatively, values, goals, method used to achieve goals, traits, characteristics used to describe people, actors, who is being discussed, authority, in whose name the statements are being made, location, conflict, sources and levels, and endings, how conflicts are resolved. This stage, that is, constructing the categories, is sometimes termed the creation of a domain analysis. This involves grouping the units into domains, clusters, groups, patterns, themes, and coherent sets to form domains. A domain is any symbolic category that includes other categories. A domain is any symbolic category that includes other categories. At this stage, it might be useful for the researcher to record the data into domain codes or to review the codes used to see how they naturally fall into clusters, perhaps creating overarching codes for each cluster. Utilization is the next, and utilization is the process of putting data into meaning units for analysis, examining data, and identifying what those units are. A meaning unit is simply a piece of datum which the researcher considers to be important. It may be as small as a word or a phrase, or as large as a paragraph, groups of paragraphs, or indeed a whole text, provided that it has meaning in itself. Spradley, 1979, suggests that establishing domains can be achieved by 4 analytic tasks. Number 1, selecting a sample of verbatim interview and field notes. Number 2, looking for the names of things. Number 3, identifying possible terms from the sample. And number 4, searching through additional notes for other items to include. He identifies 6 steps to achieve these tasks. And these 6 tasks are these. Number 1, select a single semantic relationship. Number 2, prepare a domain analysis sheet. And number 3, select a sample of statements from respondents. And number 4, search for possible cover terms and include those that fit the semantic relationship identified. Number 5, formulate structural questions for each domain identified. And number 6, list all the hypothesized domains. So domain analysis strives to discover relationships between symbols. Like codes, categories can be at different levels of specificity and generality. Some categories are general, overarching, others are less so. Typically, codes are much more specific than categories. This indicates the difference between nodes and codes. A code is a label for a piece of text. A node is a category into which different codes fall or are collected. A node can be a concept, idea, process, group of people, place, or indeed any other grouping that the researcher wishes it to be. It is an organizing category, whereas codes describe specific textual movements. Nodes draw together codes into a categorical framework, making connections between coded segments and concepts. It is rather like saying that a text can be regarded as a book, with the chapters being the nodes and the paragraphs being the codes, or the content page being the nodes and the index being the codes. Nodes can be related in several ways. For example, one concept can define another. They can be logically related and they can be empirically related. Step number 8. Conduct the coding and categorizing of the data. Once the codes and categories have been decided, the analysis can be undertaken. This concerns the actual ascription of codes and categories to the text. Coding has been defined by Kalinga, 1970, as the translation of question responses and respondent information to specific categories for the purpose of analysis. Many questions are pre-coded, that is, each response can be immediately and directly converted into a score in an objective way. Rating scales and checklists are examples of pre-coded questions. Coding is the ascription of a category label to a piece of data, which is either decided in advance or in response to the data that have been collected. Mehring suggests that summarizing content analysis reduces the material to manageable proportions while maintaining fidelity to essential contents, and that inductive category formation proceeds through summarizing content analysis by inductively generating categories from the text material. This is in contrast to explicit content analysis, the opposite of summarizing content analysis, which seeks to add in further information in the search for intelligible text analysis and category location. The former reduces contextual detail, the latter retains it. Structuring content analysis filters out parts of the text in order to construct a cross-section of the material using specified preordinate criteria. It is important to decide whether to code simply for the existence or the incidence of the concept. And this is important, as it would mean that in the case of the former, existence, the frequency of a concept would be lost, and frequency may give an indication of the significance of a concept in the text. Further, the coding will need to decide whether it should code only the exact words or those with a similar meaning. The former will probably result in significant data loss, as words are not often repeated in comparison to the concepts that they signify. The latter may risk losing the nuanced sensitivity of particular words and phrases. Indeed, some speech makers may deliberately use ambiguous words or those with more than one meaning. In coding a piece of transcription, the researcher goes through the data systematically, typically line by line, and writes a descriptive code by the side of each piece of datum. For example, text and code. If the text is, the student will undertake problem solving in science. So you can code it as prob, stands for problem. I prefer to teach mixability classes. You can code this sentence as mixable. One can see that the codes here are abbreviations enabling the researcher to understand immediately the issue that they denote because they resemble the issue, rather than, for example, ascribing a number as a code for each piece of datum, where the number provides no clue as to what the datum or category concerns. Where they are not abbreviations, Miles and Huberman suggest that the coding label should bear sufficient resemblance to the original data so that the researcher can know by looking at the code what the original piece of datum concerned. Step number 9. Conduct the data analysis. Once the data have been coded and categorized, the researcher can count the frequency of each code or word in the text and the number of words in each category. This is the process of retrieval, which may be in multiple modes. For example, words, codes, nodes, and categories. Some words may be in more than one category. For example, where one category is an overarching category and another is a subcategory. To ensure reliability, Weber suggests that it is advisable at first to work on small samples of text rather than the whole text, to test out the coding and categorization and make amendments where necessary. The complete text should be analyzed as this preserves their semantic coherence. Words and single codes on their own have limited power, and so it is important to move to associations between words and codes, that is, to look at categories and relationships between categories. Establishing relationships and linkages between the domains ensures that the data, their richness and context groundedness are retained. Linkages can be found by identifying confirming cases, by seeking underlying associations and connections between data subsets. Weber suggests that it is preferable to retrieve text based on categories rather than single words, as categories tend to retrieve more than single words. Drawing on synonyms and conceptually close meanings, one can make category counts as well as word counts. Indeed, one can specify at what level the counting can be conducted. For example, words, phrases, codes, categories, and themes. The implication here is that the frequency of words, codes, nodes, and categories provides an indication of their significance. This may or may not be true, since subsequent mentions of word or category may be difficult in certain texts, for example, speeches. Frequency does not equal importance, and not saying something, withholding comment may be as important as saying something. Content analysis analyzes only what is present rather than what is missing or unsaid. Pronouns may replace nouns further on one goes through a passage. Continuing raising of the issue may cause redundancy, as it may be counterproductive repetition. Constraints on text length may inhibit reference to the theme. Some topics may require much more effort to raise than others. The researcher can summarize the references from the text, look for patterns, regularities, and relationships between segments of the text, and test hypotheses. The summarizing of categories and data is an explicit aim of statistical techniques, for these permit trends, frequencies, priorities, and relationships to be calculated. At the stage of data analysis, there are several approaches and methods that can be used. Krippendorf suggests that these can include extrapolations such as trends, patterns, and differences, standards, evaluations, and judgments, indices, for example, of relationships, frequencies of occurrences and co-occurrences, number of favorable and unfavorable items, linguistic representations. Once frequencies have been calculated, statistical analysis can proceed using, for example, factor analysis, means to group the kinds of response, tabulation of frequencies and percentages, cross-tabulation, presenting a matrix where the words or codes are the column headings and the nominal variables, for example, the newspaper, the year, the gender, are the row headings. Correlation, to identify the strength and direction of association between words, between codes, and between categories. Graphical representation, for example, to report the incidence of particular words, concepts, categories over time or over text. Regression, to determine the value of one variable, word, code, category in relationship to another. A form of association that gives exact values and the gradient or slope of the goodness of fit line of relationship. The regression line, multiple regression, to calculate the weighting of independence on dependent variables, structural equation modeling, and LISREL. Analysis, to determine the multiple directions of causality and the weightings of different associations in a pathway analysis of causal relations. And dendrograms, tree diagrams, to show the relationship and connection between categories and codes, codes and nodes. While conducting qualitative data analysis using numerical approaches or paradigms may be criticized for being positivistic, one should note that one of the founders of grounded theory, Glaser 1996, is on record as saying that not only did grounded theory develop out of a desire to apply a quantitative paradigm to qualitative data, but also paradigmal purity was unacceptable in the real world of qualitative data analysis, in which fitness for purpose should be the guide. Further, one can note that Miles and Huberman, 1984, strongly advocate the graphic display of data as an economical way of reducing qualitative data. Such graphics might serve both to indicate causal relationships as well as simply summarizing data. Step number 10, summarizing. By this stage, the investigator will be in a position to write a summary of the main features of the situation that have been researched so far. The summary will identify key factors, key issues, key concepts, and key areas for subsequent investigation. It is a watershed stage during the data collection, as it pinpoints major themes, issues, and problems that have arisen so far from the data and suggests avenues for further investigation. The concepts used will be a combination of those derived from the data themselves and those inferred by the researcher. At this point, the researcher will have gone through the preliminary stages of theory generation, and Pattern 1980 sets these out for qualitative data. What are they? Finding a focus for the research and analysis, organizing, processing, ordering, and checking data. Number 2, writing a qualitative description or analysis inductively, developing categories, typologies, and labels. Number 3, analyzing the categories to identify where further clarification and cross-clarification are needed. Number 4, expressing and typifying these categories through metaphors. And number 5, making inferences and speculations about relationships, causes, and effects. Bogdan and Bicklin, in their study 1992, identify several important factors that researchers need to address at this stage, including forcing oneself to take decisions that will focus and narrow the study and decide what kind of study it will be, developing analytical questions, using previous observational data to inform subsequent data collection, writing reflexive notes and memos about observations, ideas, what is being learned, trying out ideas with subjects, analyzing relevant literature while conducting the field research, generating concepts, metaphors, and analogies, and visual devices to clarify the research. Step number 11, making speculative inferences. This is an important stage, for it moves the research from description to inference. It requires the researcher, on the basis of the evidence, to posit some explanations for the situation, some key elements, and possibly even their causes. It is the process of hypothesis generation or the setting of working hypotheses that feeds into theory generation. The stage of theory generation is linked to grounded theory, and I will turn to this in a minute. Here I will provide an example of content analysis that does not use statistical analysis, but which nevertheless demonstrates the systematic approach to analyzing data that is at the heart of content analysis. At a wider level, The limit of content analysis are suggested by Azzi, who argues that due to the preordinate nature of coding and categorizing, content analysis is useful for testing or confirming a pre-existing theory rather than for building a new one. Though this perhaps understates the ways in which content analysis can be used to generate new theory, not least through a grounded theory approach. I'll discuss it later on what the grounded theory is. In many cases, content analysis know in advance what they are looking for in text, and perhaps what the categories for analysis will be. As he suggests that this restricts the extent to which the analytical categories can be responsive to the data, thereby confirming the data analysis to the agenda of the researcher rather than the other. In this way, it enables pre-existing theory to be tested. Indeed, Mehring 2004 argues that if the research question is very open, or if the study is exploratory, then more open procedures than content analysis, for example, grounded theory, may be preferable. However, inductive approaches may be ruled out of the early stages of a content analysis, but this does not keep them out of the later stages, as themes and interpretations may emerge inductively from the data and the researcher rather than only unnecessarily from the categories or pre-existing theories themselves. Hence, to suggest that content analysis denies induction or is confined to the testing of pre-existing theory is uncharitable. It is to misrepresent the flexibility of content analysis. Indeed, Flick 1998 suggests that pre-existing categories may need to be modified if they do not fit the data. Now I will turn to the other part of this lecture, that is about the grounded theory. Theory generation in qualitative data can be emergent, and grounded theory is an important method of theory generation. It is more inductive than content analysis, as the theories emerge from rather than exist before the data. Strauss and Corbin 1994 remark, grounded theory is a general methodology for developing theory that is grounded in data systematically gathered and analyzed. There are several features of this definition, such as theory is emergent rather than predefined and tested. Theory emerges from the data rather than vice versa. Theory generation is a consequence of and partner to systematic data collection and analysis. Patterns and theories are implicit in data waiting to be discovered. Glaser 1996 suggests that grounded theory is the systematic generation of a theory from data. It is an inductive process in which everything is integrated and in which data pattern themselves rather than having the research pattern them. As actions are integrated and interrelated with other actions. Glaser and Strauss, seminal work 1967, rejects simple linear causality and the decontextualization of data, and argues that the world which participants inhabit is multivalent, multivariate, and connected. Glaser says the world doesn't occur in a vacuum, and the researcher has to take account of the interconnectedness of actions. In every life, actions are interconnected and people make connections naturally. It is part of everyday living, and hence grounded theory catches the naturalistic element of research and formulates it into a systematic methodology. Grounded theory is faithful to how people act. It takes account of apparent inconsistencies, contradictions, discontinuities, and relatedness in actions. Grounded theory is a systematic theory using systematized methods of theoretical sampling, coding, constant comparison, the identification of a covariable, and saturation. Grounded theory is not quantitative methods. It arose out of them in terms of trying to bring to qualitative data some of the analytic methods applied in statistical techniques. In grounded theory, the researcher discovers what is relevant, the discovery. Indeed, Glaser and Strauss' work is entitled The Discovery of Grounded Theory. However, where it parts company with much quantitative positivist research is in its view of theory. In positivist research, the theory pre-exists its testing, and the researcher deduces from the data whether the theory is robust and can be confirmed. The data are forced into a fit with the theory. Grounded theory, on the other hand, does not force data to fit with a predetermined theory. Indeed, the difference between inductive and deductive research is less clear than it appears to be at first stage. For example, before one can deduce, one has to generate theory and categories inductively. Grounded theory starts with data, which are then analyzed and reviewed to enable the theory to be generated from them. It is rooted in the data and little else. Here the theory derives from the data. It is grounded in the data and emerges from it. As Lincoln and Guba, 1985, argue, grounded theory must fit the situation that is being researched. Glaser, 1996, writes that forcing methodologies were too ascendant, not least in positivist research, and that grounded theory had to reject forcing or constraining the nature of a research investigation by pre-existing theories. As grounded theory sets aside any preconceived ideas, letting the data themselves give rise to the theory. Certain abilities are required of the researcher. For example, tolerance and openness to data and what is emerging, tolerance of confusion and regression, feeling stupid when the theory does not become immediately obvious, resistance to premature formulation of theory, ability to pay close attention to data, willingness to engage in the process of theory, generation rather than theory testing. It is an experiential methodology, ability to work with emergent categories rather than preconceived or received categories. As theory is not predetermined, the role of targeted pre-reading is not as strong as in other kinds of research, using literature reviews to generate issues for the research. Indeed, it may be dangerous as it may prematurely close off or determine what one sees in data. It may cause one to read data through given lenses rather than anew. As one does not know what one will find, one cannot be sure what one should read before undertaking grounded theory. One should read widely both within and outside the field, rather than narrowly and in too focused a direction. There are several elements of grounded theory that contribute to its systematic nature, and it is to these that I now turn. Theoretical sampling. In theoretical sampling, data are collected on an ongoing iterative basis, and the researcher keeps on adding to the sample until there is enough data to describe what is going on in the context or situation under study, and until theoretical saturation is reached. As one cannot know in advance when this point will be reached, one cannot determine the sample size or representativeness until one is actually doing the research. In theoretical sampling, data collection continues until sufficient data have been gathered to create a theoretical explanation of what is happening and what constitutes its key features. It is not a question of representativeness, but rather a question of allowing the theory to emerge. Theoretical sampling is the process of data collection for generating theory, whereby the analyst jointly collects, codes, and analyzes his data, and decides what data to collect next and where to find them, in order to develop his theory as it emerges. This process of data collection is controlled by the emerging theory. The basic criterion governing the selection of comparison groups for discovering theory is their theoretical relevance for furthering the development of emerging categories rather than, for example, conventional sampling strategies. Coding. Coding is the process of disassembling and reassembling the data. Data are disassembled when they are broken apart into lines, paragraphs, or sections. These fragments are then rearranged through coding to produce a new understanding that explores similarities, differences across a number of different areas. The early part of coding should be confusing with a mass of apparently unrelated material. However, as coding progresses and themes emerge, the analysis becomes more organized and structured. As coding proceeds, the researcher develops concepts and makes connections between them. And Flick argued that repeated coding of data leads to denser concept-based relationships, and hence to a theory that the richness of the data is included in the theoretical formulation. Constant comparison. The application of open, axial, and selective coding adopts the method of constant comparison. In constant comparison, the researcher compares the new data with existing data and categories so that the categories achieve a perfect fit with the data. Glaser and Strauss write that the purpose of the constant comparison method of joint coding and analytic procedures, that theory is not intended to ascertain universality or the proof of suggested causes or other properties. Since no proof is involved, the constant comparison method requires only saturation of data, not consideration of all available data. The second stage involves memoing and further coding. Here the constant comparison units change from comparison of incident with incident to comparison of incident with properties of the category that resulted from initial comparison of incidents. The third stage of delimitation occurs at the levels of the theory and the categories, and in which the major modifications reduce as underlying uniformities and properties are discovered, in which theoretical saturation takes place. And the final stage of writing theory occurs when the researcher has gathered and generated coded data, memos, and a theory, and this is then written in full. So that our topic was content analysis and grounded theory as research methods. Thank you very much for listening, and goodbye.